Hi, my name is Bill Hunt. I'm the CTO of Dianomic, and in this video I'm going to give you an overview of FogLAMP. Now in the industrial world, it's pretty clear every day sensors are getting cheaper and smaller. Every day compute cost and storage cost is going down. Every day there are more tools to analyze and process the data that's out there, and every day everything is more and more connected. So you put all these things together and it's pretty obvious that industrial IoT can enable digital transformation across industrial businesses. One of the things that we're seeing a lot of are the emergence of secondary networks or overlay networks. In the core of industrial companies are SCADA systems or PLC systems. They're secure, they're reliable, but they're also tightly regulated, sometimes by government mandate. And oftentimes they aren't close to the data that you want to bring in, the IoT data that you want to bring in. They can be quite expensive, not just because of the per point cost on hardware, but also because you need to do security reviews, other kinds of IT reviews, various kinds of perhaps even regulatory reviews. And so the networks of these non-SCADA data are becoming more common. Now, one of the problems is that you've got massive fragmentation across all the types of sensors that are out there, a lot of complexity. And another problem is that you have a large brownfield that you need to support and extend. Now, the new kinds of IoT data that are brought into industrial companies can be used for all kinds of valuable things. But one of the things that is the most important is efficiency. It's about predictive maintenance. If you have very large assets, multi-million-dollar assets, it's really key that they're up all the time and that they're always in use and that they're producing high-quality work. And so being able to predict when they require maintenance is an important thing to do. So sometimes that's as simple as just knowing what the temperature is on the other side of, say, a factory. And sometimes it's more complex. Perhaps you want to even be running various machine learning models to detect when anomalies are happening or when there are failures or when they require maintenance. So what Dianomic does is we provide FogLAMP. It's this industrial IoT fabric. It's open source, and it's looking to transform businesses from sensor to cloud. So a single FogLAMP unit can do these things. It can collect data from any kind of source. If you have a lot of fog lamps, it can aggregate the data and combine it in meaningful ways. As it flows through, the data can be transformed to enrich it or to filter it. It can be buffered, so if a fog lamp is living out on a haul truck going through a mine or out in a cabinet on an oil rig, it can be buffered if you lose connectivity so you don't lose anything. You can do edge analytics so that you can understand how the data looks and operates close to that data. And you can deliver the data to one or more local or cloud destinations. So that's what a single fog lamp does. It connects a sensor to a destination. But you can have multiple sensors going into a fog lamp. You can send it to multiple destinations. You can also send data from one fog lamp to another fog lamp. So with that, you can build hierarchies or meshes of data. You can really build these data routing fabrics, and along the way you can be transforming that data in meaningful ways. You can have redundancy, so if hardware fails, you don't lose anything. And you can build these distributed applications across all of the different fog lamps that you've got. FogLAMP is designed like a cable modem. You turn it on, you turn it off, you turn it on, you turn it off. It just always works. It's designed to be very easy to provision and maintain. If you're building your own, it's very small. It requires less than 50 meg of memory plus an OS, and it's quite fast at moving data around. It's available on a variety of different kinds of hardware. The three bottom ones are from Advantech and Nexcom, and the one on the left is SmartCone, who makes a industrial gateway that can be mounted on telephone poles or on construction sites. It can be run on Cisco in a container, very Cisco devices, and it can be run on Raspberry Pis, which you wouldn't really use for production, but they're great for doing POCs and doing development, and then you can take the code that you put together on a Raspberry Pi and roll it out to industrial applications. This is the architecture. Each of the blue boxes is a plugin, And there are lots of plugins out there, but if the plugin that you need doesn't exist, it's very easy to create your own. Whether you do it, whether a company does it, whether a systems integrator does it, or whether we do it, it's easy to create them. So the data flows from the south, from sensors, through the storage layer where it's buffered, and then out the north surface where it's sent to some destinations, such as OSI Soft's Pi, or via Kafka or Splunk, or to a cloud service. And along the way, it can flow through these enhancers on the lower side, where it can be the data can be enriched, or it can also flow through filters on the north side, where it can be regulated how much data is sent. And then in there's an event engine which can run rules against the data to detect anomalies, and then based on the results of those rules, it can take various actions. There's an orchestrator that keeps everything running sanely, so it's got self-healing capabilities. If there are any problems, it can do backup, it schedules various things. Security is all contained there. At the top, there's a GUI, and the GUI acts through a REST API. So through that, if you don't, you can use the GUI, it's full-featured, but you can also control FogLAMP using scripts or with other management tools. So on the south side, there's a number of existing plugins. You can pull in temperature, humidity, currents, pressure data, various sensor protocols in the industrial world are supported, Modbus, OPC UA, MQTT, etc. But again, it's pluggable, so it's very easy to create your own. There's APIs and sample code. We support Python or C++. Python is good for fast development. C++ is good for high performance. They can be polled or async. And because it's open source, in time we expect a large number of these plugins to exist from the community. As the data is flowing through, it can be transformed. So some of the existing transformations that we have, there's one that applies an arbitrary mathematical equation. So you can do something as simple as translating from Fahrenheit to Celsius, or you could do more complex things. You could have voting across multiple sensors. You could have, if one sensor is, say, linear and another one is logarithmic, you could compare them or add them together with the appropriate math. There's another one that modifies the data about the data, the metadata values. So as data is flowing through a FogLAMP, you can tag the data with the city or the floor or the machine or the factory that the data has come from. Or in the case of discrete manufacturing, you can tag the data with the component that's actually being manufactured. You can summarize high frequency data. If you've got very high volume data, it can send data that's more relevant and more rich than the original. We'll talk about that in a bit. And you can transform data using machine learning capabilities. We'll talk a little bit more about that too. And again, you can it's all pluggable, so it's very easy to create your own transformations. You can intelligently reduce the data flow as it's flowing out, so you're not wasting valuable network or resources in other machines. So you can compress the data, you can only send the deltas, or you can intelligently reduce it. So you can say collect data at maybe 1,000 samples a second, but not send it forward. And then if you detect an error condition, maybe you'll send the last 30 minutes or last 5 minutes of data. So that way you kind of have the best of both worlds, that whenever there are error conditions, you don't lose any of that data. It's all sent forward. But when you have data that's maybe not so meaningful, you don't send it forward. If you look at a graph of temperature data, it's pretty obvious what it means. You can say it was cold over here, it's hot here. If it gets too hot, I want to set an alert. But when you're collecting vibration data, it's not so obvious what it means. You can look at a graph and you can't derive anything from it. And you can't really create any thresholds either. And on top of that, temperature data is relatively low volume, right? You can collect one sample a second, maybe even one sample a minute, and get some meaningful value out of it. But vibration data can be 1,000 samples a second, maybe even 1,000,000 samples a second. So now you're collecting data that really isn't obvious what it's doing, and it's at extremely high volume. So what do you do to solve this problem? Well, there's a couple filters that come with FogLAMP. The first one is called root mean squared, or RMS. And what it does is it calculates the vibration, or the energy of a vibration. So you get a graph similar to what you see on the left. And here you can see low speed or high speed, and you can start to set thresholds around what it is. And then we also have another plugin called FFT, or Fast Fourier Transform. And what this does is it takes the vibration data and it breaks it down into its component waves. And so you can look at this and you can see what's normal. You can set a baseline. And then if you see changes in that, you can detect wobbles or oscillations and predict problems or failures. You can also use machine learning. So you can point a camera, you can hook a camera up to FogLAMP and point it at, say, a welding machine, and you can detect, is this a good weld or is this a bad weld? You can point it at some area where there shouldn't be people, and if it detects faces, then you know that they shouldn't be there, and you can set off an alert. And it can also use machine learning to look at a data stream and detect if there's a problem, if there's some kind of anomalous behavior. And we're working with Google. We've got TensorFlow Lite ported into FogLAMP to do this. You can do various image recognition things, object detection, or anomaly detection. We're also working with FLIR. They're a premium infrared camera company. So you can take a FLIR camera and you can point it at an area, say a factory floor, and you can draw bounding boxes around various pieces of equipment, and it will tell you the min, max, average temperature for those devices. And then we also have an event engine built into FogLAMP. So there are two types of rules or two types of plugins in the event detection engine. One is rules. So you can have very simple rules like, if the temperature goes over 50, I want to trigger an event, or it could be much more complex. We have support sliding windows. You can look at the average of the last 15 minutes and detect if you've gone above some threshold in that, or you could even have a machine learning rule that's looking across something much more complex. And then once a event is triggered, you can take actions. You can create asset data that can flow to other systems so they can take action on it. You can run an external Python application inside FogLAMP, so that inside the FogLAMP device, so that you could say flash a light or turn off some machine or run a siren, that sort of thing. Or you could send a notification via email, Slack, some other kind of messaging. And again, it's pluggable, so for the rules and actions, it's very easy to create your own. Out of the box, FogLAMP has a GUI that you can do all the setup, configuration, monitoring, and analytics. It's all done via REST, so you can use your own automated scripts or your own management console to manage FogLAMP. And if you already manage Linux devices, you can use typical tools like Puppet or Chef to manage FogLAMP devices. We have a centralized management that's currently in development that'll be out at the end of 2019. And some of the capabilities, it can do auto discovery. So when you bring up a new FogLAMP, it can discover it. You can manage multiple devices in one centralized location. So you can manage a lot of FogLAMPs at scale. You can do mass software updates and configuration changes. You can deploy software immediately or schedule it. You can do rollbacks. You can do templating. You can manage metadata across your entire system. And it's all either on-prem or cloud-based. And it also enables monitoring of the data, both the health of the devices and services, as well as the data about the data itself. FogLAMP is now part of the Linux Foundation. So the Linux Foundation is started LF Edge to build a set of open source a stack of open source services to enable the Edge, and Dianomic is a premier member of that. FogLAMP Edge, known as Fledge, is the name of FogLAMP inside LF Edge. Some use cases in the energy world. FogLAMP is used to collect data across the current data across pitch motors in wind turbines to detect when there will be failures within them. FogLAMP is used to monitor transformers and substations. In this particular customer, it's running inside a Cisco in a container, and data is sent both to OSIsoft, which is the we're the center of their data, but it's also sent via Kafka to an ERP trouble ticketing system to generate trouble tickets if there are problems. FogLAMP is also used to detect the level of chemical tanks in an energy company. And using FLIR, a energy company is monitoring their transformers. Another company is monitoring water and wastewater using FLIR. And a mining company is using FogLAMP to monitor slurry pumps to detect cavitation and maintenance needs and failure needs. And FogLAMP is also deployed in a factory which makes aircraft, collecting temperature and humidity data in the paint booths. So that's FogLAMP. I hope this has been valuable, and we'd love to talk to you. We're at info@dianomic.com, or come visit us at dianomic.com. Take care.